Yesterday we talked about Alfred Wegener and continental drift. And so today we're going to finish up the discussion by talking about the theory of plate tectonics, because he could not fully explain what force could cause the continents to move. So Alfred Wegener and the hypothesis of continental drift was that all of the Earth, all the continents were together in one big supercontinent called Pangea, meaning all Earth. And this is around 1910. He couldn't fully explain what could possibly cause the continents to move, and he also wasn't a geologist, so it wasn't really well accepted until after his death, around 1960, when other evidence was found. Now, we started out today asking about what is seafloor spreading and why is it important. In fact, seafloor spreading is the evidence that was needed to show that the continents were in fact moving. So, along the mid-Atlantic ridge, in the middle of the Atlantic Ocean, using ships and sonar, scientists mapped this very large mountain range. It's actually the largest mountain range on the planet. It goes all the way through the ocean. And if you look on Google Earth, I showed you this at the beginning of class, but if you look here, you can see it here through the Atlantic Ocean and going right between Africa and South America. So you see, these are the two continents that you can see that best fit. This is the mid-Atlantic ridge, and it's pushing apart. Now, what evidence, aside from just there being a mountain range, what evidence did scientists find that show that this is indeed happening? 3 types of evidence that show it was happening. Yes, what's one of them? Okay, so molten material. The scientists could actually see the that the new rock was forming. There's newer rock towards the middle and older rock further away. So we got seafloor spreading here. Molten material, you can see it's coming up and pushing the material away on either side. What other evidence did they have that this was actually happening? Yes? Magnetic stripes. Now, that's a little odd, right? It turns out that because of the magnetic poles of the Earth, as this molten material, which is very high in iron, it lines up magnetically. And if it's melted, the electrons can move around, and it actually makes a magnetic pattern. And it turns out that over, thousands of years, hundreds of thousands of years, the magnetic pole moves slightly. And so with that movement, it actually changes the way the magnetic orientation of the rocks are. And so in further evidence that the seafloor spreading is happening, if you look at, here's the magma, volcanic activity at the ocean ridge. This rock is the same as this rock, of course, but you go further out, this rock is the same as this rock, and this rock is the same as this rock. And so they can map and actually have scientific evidence, data that this is indeed happening. Okay, and then the third line of evidence that this is actually happening was what? Evidence from drilling. Remember that one? And so the evidence from drilling is it simple. So let's move on. Let's move on. So next, and guys, one of the other things that will be on the quiz is the different type of boundaries. So interesting thing with plate tectonics, because you have new crust being formed here, if new crust was formed and just kept forming and forming and forming, well, then the Earth would be getting bigger, right? But the Earth's not getting bigger, so what must be happening somewhere else? If it's being, it has to, yes? Yeah, so if it's being, new crust is formed here, it must be destroyed somewhere else. And so what happens in spreading ridges, it's making more. And then in other areas called subduction zones, the ocean crust, which is more dense than the continental crust, it's getting pushed under. And it pushes under and pushes under and eventually gets shoved down into the mantle and melted. I believe we have a better picture of that. So we'll talk about the different types of, well, here's the different plates. We'll come back to that in a minute. But the different plates, and this is showing you the major plates: Pacific, Eurasian, North American, African, South American, Antarctic, Indo-Australian. So the plates roughly correlate with the continents. There are some other ones. You've got the Caribbean plate that's under the Caribbean Sea here. And then you've got a bunch of little ones. There's a little plate here, and there's some tinier plates in here. And so when you have the littler plates near plate boundaries, that's where we're going to have earthquakes and volcanoes, which is what we'll start talking about next week. But if you start thinking about this, you've got two plates here. Here's California. We have earthquakes. Here's the Pacific Northwest. Those are volcanic mountains. Japan. Let me back up here and see Japan. Japan's over here, and volcanic activity and earthquakes. All right. So the three major types of plate boundaries, you make sure you know these. It's pretty self-explanatory, right? There's divergent boundaries where they're diverging. The two plates are moving apart. New crust is being formed. This can also be called a constructive boundary because new crust is being made. Okay? Then you can have a convergent boundary where the two plates are moving together, and that is generally a destructive boundary. A couple things can happen at a convergent boundary. You can either have the two plates coming together and one gets shoved underneath the other, or you can have them coming together and they both go upwards and make mountains. And then the third type is transform boundaries, where the plates move side by side. And here you get earthquake activity generally, but not, crust is not made nor destroyed. Since we're just introducing this today and the quiz is tomorrow, I'll probably have a little bit of this on tomorrow's quiz, but next week, as we continue to talk about this and start talking about earthquakes, this becomes even more important because the type of boundary affects if there's earthquakes or volcanoes and how severe of earthquakes or volcanoes. Okay? Everyone got the three major plate boundaries? Divergent, convergent, transform? And this is also in your packet, right? On the last two pages. On the quiz, what you'll need to know for the quiz are the three basic boundaries: divergent, convergent, transform. Okay? If you look at your worksheet packet, starting on the place where it says the theory of plate tectonics, everybody see that? Okay. I'm going to go over which stuff you need to know and which stuff we'll push into next week. Okay? So write this down, get out your packet, and I'll go over what exactly you need to know for this week and which is for next week. As you write this down, these next few slides just go over the same thing in a little bit more detail. And so you do need to know these three types: the divergent boundary. And again, don't worry so much about the type of crusts. This is what we'll talk about next week. The type of features that are formed, oceanic, continental. So don't worry about that. But divergent does happen at the mid-ocean ridge. New crust is formed, right? We talked so much about seafloor spreading. That should make sense. It's a constructive boundary because new crust is being formed. Convergent boundary. And again, next week we'll go into more detail on this because different things can happen depending on where the convergent boundary is occurring. So what you need to know is simply that the convergent boundary is where two plates are running into each other, coming together. And crust can be destroyed at a convergent boundary. And then finally, the transform boundary, they're moving side by side, and crust is neither created nor destroyed. So those are the three major types. And next week we'll pick up with more detail on that. So now we'll take a quick look at the worksheet packets and what you need to know.